This lesson is on 6.6, which is called scale drawings. So first let's go through some vocabulary that might be important for us to know. Scale drawing. A scale drawing is a two-dimensional drawing that is similar to the object it represents. Keyword here, similar, just like you learned in the last previous section. Similar shapes are the same ratio. So for example, this, and this won't be exact because I'm drawing it by hand, this square we could say is similar to this as long as the ratio of this each side is the same. So they're similar to the object it represents, and it's two-dimensional. A model, scale model, is three-dimensional model that is also similar to the object it represents. So the difference between a drawing and a model is just 2D compared to 3D. And then last, the scale. You may have seen this on maps a lot. So the scale of a drawing or scale of a model gives the relationship between the drawing or the model's dimension. So sometimes on a map you might see a 1-inch distance actually is, say, 20 miles. So our actual scale is 1 inch over 20 miles. It's that ratio that we've been using in the previous sections. So that would be our scale. Let's try a problem. So using a scale drawing is the first example type. So the distance on a map from Toronto, Canada to Ottawa, Canada is 9 centimeters. So it's 9 centimeters on the map, and the scale is 1 centimeter to 25 miles. What is the actual distance between the two cities? So what we're going to do is we're going to let X represent the actual distance in miles between Toronto and Ottawa, because that's the part we don't know. We want to find the actual distance. The way we can set this up is we can say the scale, 1 centimeter over 25 miles, equals the map distance, the actual map distance here, to the actual distance. So we always put our map distance on top and then our actual distance on the bottom, because we need to have the same units on top that are on the bottom. Now you can use your favorite method to solve for this. You can either multiply the top and bottom by 9, or you could cross multiply, but you're going to, if you cross multiply, it's pretty easy because you get 1x equals 9 times 25. Well, 9 times 25 is 225, so the actual distance is 225 miles. So what I'd like you to do is go ahead and try this example down here. This time it's using a blueprint. A blueprint is just like a map for building. So if 1 inch equals 3 feet, or the ratio is 1 inch to 3 feet, and the actual length of the living room is 18 feet, can you find the length of the living room on the blueprint? So now remember, you're looking for this value when you set up your ratio. Your ratio will change, but your unknown is now the actual distance on the, it's not the actual distance, it's the blueprint distance. So go ahead and press pause and give that a try. Example 2. So what if you have to find the scale? They don't give you the scale, you actually have to find it. So a gardener is making a scale drawing of a garden. The length of the actual garden is 9 yards. The length of the garden in the drawing is 3 inches. So what is the scale of this? Well, in this case, we just need to make it a ratio where the scale always goes on top and actual on the bottom, and we need to simplify it. So we end up getting 1 inch is equivalent to 3 yards. So I want you to go ahead and try one on your own. So if the distance between two cities on a map is 12 millimeters, find the actual distance between, and the actual distance is 60 miles. What is the scale of this map? So it's 12 millimeters on the map, actual is 60. Find that scale. So press pause now. And the last example is finding a dimension of a scale model. So a model of a building has a scale of 1 to 40. If they don't give you units, that means that these units are the same. So the building is 100 feet tall. Find the height of the model. So in this case, we can say 1 to 40 is equal to the model divided by the actual. So here, our model's on top, our actual's on the bottom. So we use the same scale to say model, actual. Then we can solve for x. So in this case, we can cross multiply, so we get 40x equals 100, then divide by 40, and we get x equals 2.5. So our answer would be the model's height is 2.5 feet. So remember, you still have to put in the units. If it's not written here, it's the same units that the other measurement is in. So last example, give this a try tonight. If you had a model boat that has a scale of 1 to 15, the model's length is 2 feet. What would be the actual length of the boat? This should say models. So find the actual length of the boat. Press pause and give it a try, and that's it for today.